Today we'll be talking about AI and machine learning, specifically the bit on machine learning. And yeah, we're going to have two case studies, one for natural language processing, sentiment analysis, and then we'll also do image classification. So before we start, I'd want to pose a question or like a thought experiment. So now let's assume we're expecting another Martin to join the team. So yeah, let's imagine that our new Martin has never seen a chair before. So yes, how would you explain to them what a chair is? And yeah, I want to hear from all of us, starting with Malvin, Adam, Leonard, Dominic, and then Edgar. So yes, Malvin, how do you explain to him what a chair is?
Okay, being that he has not seen a chair before, so the only way I can make him understand or know about a chair is simply having some sample photos of what a chair is. So I would go search for sample photos, maybe through a Google search. Then I'll show Martin those particular photos so that at least he can have a glimpse on what a chair is. So that's how I'll go about it.
Okay, thank you, Malvin. How about you, Adam?
I think mine, the way I would define, assuming I don't have the images, I would just be able to explain to anyone, like the chair is just something that you're able to sit on. Simple.
Table.
It could be a table if you want to go ahead and dig deeper. And a table can actually be a chair too. Now, if you're going into that depth, then maybe we would talk about the dimensions, saying it can fit up to it's this tall, going into more dimensions metrics. But just at the very first snapshot, you'd say, yeah, a chair is something that you actually sit on, and it can sit one person, sometimes two people. And, just that's it. Again, no images. Sorry, go ahead.
Okay, yeah, thank you for that. Leonard, how about you?
This is a thought-provoking question. So I think the way I would describe it is something that has four legs. And then if I have a pen and paper, maybe draw it out. Has four legs. It has where I can be able to put my back on and then be able to sit on it with my legs, whatever posture. But I think the easiest for me would be take a pen and paper and just draw something that reciprocates what a chair looks like.
Okay, thank you. Dominic?
Yeah, that's an easy question and a kind of a hard question to explain because you use it every day. But what everybody has said, it's really what I could say, describe it, get a picture. But also I could like to know how much the other might know. Where is it coming from? If this the language you understand is a picture, kind of a picture, then we explain. I'll go into the picture. If it's a kind of sample doing just come from maybe the world where they look numbers, then I'll use the numbers to explain. Okay, you measure this at this height, that's the chair. If you at that level, if this length, that's the chair is maybe 1 foot, 1 foot on the 1 foot to the length, maybe a half foot to the right, and then down maybe 1 feet, 2 feet, 2 feet or a feet and a half, depending on the knowledge the other person has, the other Martin has, will determine which my explanation, either picture, even the measurements and all that.
Okay, thank you. Yeah, and finally we have Edgar. So yes.
Yeah, so with me, I'll just go with what everyone has said, like just show pictures, then describe to him like from this is what you do. Like with this, you can rest your back, you can, yeah, something of this sort.
Okay. So yeah, thank you everyone for the responses. And yes, yeah, you are all right. So yeah, basically, the responses you've given me, basically, no, that's we teaching or describing a chair to the other Martin, assuming he has never seen one. And basically, that's what machine learning is. But now, not humans, but machines. So machine learning, it's basically teaching, in this case, it would be teaching our computer to recognize a chair. So we can, there are two ways. Some of us give instructions. For example, it has 4 legs. We give it descriptions, and then some of us, like Malvin said, he would show him images, photos, and he's like, yes. So this is what a chair is. So for us, when training a computer, yes, either we can give it instructions, or the easiest way and the machine learning way is now showing it thousands or numbers of images of chairs, and then it will now start completing the pattern. It will so yeah, basically the responses you've given me, basically, no, that's we teaching or describing a chair to the other Martin, assuming he has never seen one. And basically, that's what machine learning is. But now, not humans, but machines. So machine learning, it's basically teaching, in this case, it would be teaching our computer to recognize a chair. So we can, there are two ways. Some of us give instructions. For example, it has 4 legs. We give it descriptions, and then some of us, like Malvin said, he would show him images, photos, and he's like, yes. So this is what a chair is. So for us, when training a computer, yes, either we can give it instructions, or the easiest way and the machine learning way is now showing it thousands or numbers of images of chairs, and then it will now start completing the pattern. It will now start like, oh, okay, so this is a chair, and then if we show it 1,000 photos or images of chairs, then we are so sure the next time we give it a table, it will be like, no, this is not what I've been told a chair is. Yes, so that's like the basic introduction of what machine learning is. And then, so we can quickly go through the slides of the introductions, and then go to the demo. So the fundamentals of machine learning. So like we've said, it's a subset of AI to empower our computers to learn from data without now programming it, without the instructions, now just giving it the data and empowering it to identify what is it that we gave it. So it involves the algorithms that will analyze, identify patterns, and then make predictions. So there are different ways of going about machine learning, whereby we have supervised learning, we have unsupervised learning, reinforcement, and deep learning. So For example, supervised learning is when we label the data. So in our example, we are showing Martin a photo and we tell him this is a chair. So we will tell him this is a chair, but this is a table. So that way, because we labeled what a chair is and what a table is, he'll be able to learn the difference. And then for unsupervised, for this one, you just have the data, and then how the computer will make sense of that data is by like grouping the data with specific characteristics. For example, he'll look at images of tables and chairs, and he's like, the tables don't have a backrest, but the chairs have a backrest. So okay, at this point they're not labeled, so he'll be like, some of these images have a backrest, some of these don't have. So let's have the ones with the backrest on this side and the ones that don't have on the other side. And then yeah, by grouping according to the patterns and just relationship and structures, that way will at the end we'll be able to know, oh okay, so these are the tables and then these are the chairs. And then we have reinforcement learning, which is learning through trial and error with the rewards. So yeah, an example for this is what we used to learn about training, for example, training dogs. Yeah, or just training a kid. If they do well, you give them a sweet and they'll be like, oh, so this is what I should be doing. Yeah, that's a simple example to explain that. And then for deep learning, now this is now beyond the surface, now complex, such that I'm not just looking at this face and knowing that this face belongs to a man. I'm going deeper to know that this face belongs to a man who has skin disease, who has acne, for example. So it's beyond the surface now, going deep. So yes, so this just more details about the different models. For example, supervised learning. Yeah, like we said, it's on labeled data sets, and then we have it has subsets. So an example is regression. Regression is anything that has numbers. So yeah, when you're predicting using numbers, that's regression. And then classification, we are training our models using we are categorizing our data into distinct classes. For example, we can train a model to identify spam emails, or yeah. So we'll have, because it's supervised, we have labeled this type of email is spam, and this one is, the correct one is called ham. Yeah. So yeah, that, and then the ensemble methods, now combining multiple algorithms to improve the accuracy and robustness. So example of models are the random forests, yeah, and gradient boosting machines. And then again, now digging deeper into unsupervised learning, we have clustering. So unsupervised, if you remember, we said this is when the data doesn't have a label. It's for the computer to look at it, and it's like this certain data has similar characteristics, and then yeah, that way it's able to like group this together, and then yeah. So an example, it's grouping customers based on their behaviors and spending patterns. For example, for a business, we could say parents shop more on weekends. If we check the sales week on a weekend, the people who bought more were, let's say, women, and then on Friday it was men, and then that way we can be able to predict that on weekends we should have products that are more suited to women or ladies, because those are the people we expect to see more on such a day. And then so yes, so for example, this we've talked of clustering. We then have dimensional reduction. So for this, we are now reducing the number of features, but we still maintain the essential information. So for example, our sales data set has product category, region, time. So we'll now simplify, but still we'll retain the most important features. If, for example, it's numbers in our case or sales, and yeah, now making it easier for us to visualize the trends or apply this data to our predictive models. And then yeah, we can go to deep learning. So deep learning, we said now this is the one that goes beyond the face. So for deep learning, let's say, yeah, the examples we give, if we are identifying faces, we look for simple features like the eye, the nose, the mouth, but over time, so yeah, let's assume we are teaching Martin to identify a face, not a chair at this point. So yeah, at first we'll tell him these are eyes, this nose, and then a mouth. But with time, he'll be able to see beyond the eyes, beyond the mouth. There's the jaw, and he'll note, for example, mine has a different shape from Malvin's, and then so it's the same. We are teaching the computer to do the same. Instead of just focusing on the first layer, it can go deeper and deeper. So yeah, this is through the use of neural networks. Yeah, the neurons, we know how they look like the human brain. Yes. The interconnection of nodes. So yeah, each layer will transform the data it got into a representation and output. So applications of these include things like image recognition. So when you just want to go beyond just seeing what it is to the characteristics, and then deep learning also comes in place for natural language processing in the case of sentiment analysis, because we have a review in 3 paragraphs, and we want to know, is this review positive or negative? So we need to go beyond the first line, beyond the words, to get the emotions behind the review or the comment. Yeah, so yeah, and again, the other role is now to predict. Now, once we're able to go beyond the layers, we can predict. Yeah, because the goal of machine learning majorly is predictive analysis. Yeah, so natural language processing. So this now, when we want the computers to interact with us or to understand like human beings, we want to make them intelligent. So applications include sentiment analysis, the one I mentioned. We want to go beyond this statement. What's the underlying emotion? Chatbots, for example, yeah, the bots we create, the ones we have on our website and more. When you tell it, hello, I need assistance, yeah, or when you chat with it, it's not just responding generically like hello, and just, it is able to go beyond your words to understand what do you mean and what do you exactly want, so that it can get you a tailored response. Yeah, and then computer vision, yeah, closely related to what you talked of in the deep learning, and yeah, and then the reinforcement learning, we talked about this, whereby we are rewarding the right, and yeah, that way we are training, we're able to show that this how you should go about things. And then we have the applications. Yeah, the different applications in different industries. Yeah, right now we have the Tesla, the self-driving Teslas through AI. We have healthcare through the disease diagnosis, and yeah, even the feedback for improving the patient care and outcomes. And then, yeah, for e-commerce, we have the models for predicting loans and just all of that. So, yeah, with that brief overview, then we can now go to, yeah, creating an actual model and how we go about it. So, yes. So we have two. We'll have a look at one on image classification and one on sentiment analysis. So yeah, so let's start with let me open the image classification as we yeah. So the process of creating a machine learning model is broken down into steps. The first step, of course, being what do we want to do? So we identify the problem we want to solve, and then when we have the need in mind, we now get started, and we'll start with data. As we've seen, we are training our models using data. We are showing Martin chairs so that he can be able to identify a chair on his own. We are telling our computer, if someone says excellent, then that means they are satisfied. So yeah, we need the data to train with. So that's the second step. And then after that, we now choose a model based on what we want, and then proceed with training the model. After we train the model, we have to evaluate, and then evaluate, did it like give us what we expected? And if yes, are we satisfied, or do we need to train it more? If no, do we need to add more data, or yes, how do you go about that? And then once you're satisfied, we deploy the model, and yeah, after that, like we normally do with our client projects, so after we deploy, we'll now get to the maintenance mode. Yeah, we're monitoring, and yes, so we can start with this because it's a shorter one, and then we go to the sentiment one. So for this one, this is image classification, and for this, instead of training, instead of for this one, we have like employed the Microsoft Azure custom vision model to train our model. Yes. So what we do, we just create the custom vision in our Azure platform, and then once we create, yeah, it's just creating a resource, filling in the different resource group and the pricing tier, and yes, and then once we have it, we now go to, once we have the custom vision created, we can now get into it and use it to train our model. So yeah, once we have this resource, we'll just go to customvision.ai, and then we can now, okay, we can now log in and create a project. So creating a new project, we'll just need to have the project name, and then the resource group we want to use, and then the type of model you are creating. So, because this we can either have image classification or object detection, and then how have we tagged our training data? Is it multi-label or multi-class? So we can, depending on how the data is labeled, and then the domains. So you can tell it, this is food, this is retail, or it's just general if you're training with something that's not among this. And then we just go ahead and create projects. Yeah, and then when we create a project, we get to an interface like this one, whereby we now feed in the training data. So because this one is for images, we'll just get to add images. So for example, I have two folders here. This folder is for images on microorganisms, which we have different. We have amoeba, hydra, spiral bacteria, yeast, and this is what we have. And then a different folder, we have fruits, for example, strawberry, mango, grape, banana, and apples. So at this point now you add the images, and then once you add the images, we get to train. So what you do when you add the images, you tag them. These images are for amoeba, and these ones are for Euglena, hydra, etc. So such that when you get to train, it will be identifying that all these are the amoeba. So anytime I see an image that looks like this, I should know it's an amoeba. And then and then the training depends on the amount of data that you have. So in this case, based on the images we have, the training time is 1 hour, but we don't need to wait. I've done that, so we'll just get to the testing. So once we upload the images, we're able to see the performance. Able to see the percentages. They're down here, the precision, the recall, and the average now. So yes, and I don't know if it's predictable, but ideally, the higher the image count, the higher the percentage accuracy. So from here we can proceed to test. And when you're testing, we can first use a local image, or we can have it. We can just pick any image from the website and use that to check. So this project is already uploaded on our website, so we can just use the one on our website to do the test. So we have here's the same project that we have on the Azure side on our website. So and we have the two ways we can test, either by uploading an image or having an image URL. So let's start with uploading an image, and for example, let's open this folder and just randomly pick an image and we upload. So here's the image and here's the results. So from our model, it's telling us that it has a 91% confidence that this is paramecium, 4% confidence that it's amoeba, And so the reason it's bringing this, it's because these are the this is the
Applications.
data that you've trained it with. Yes, these are the options it has to compare the image. And then we can go the URL option. And so for that one, we can just come here and look for, let's look for an list image. And then let's copy the image link and come here, paste that and submit. So let's paste the URL and submit. So yeah, this is the image, and then so we're supposed to get the results here. So let's go back here and paste the same URL here, and yes, this is the image. Okay. So the issue is the image URL. So let's come and pick another image. Go here. Okay, cute. So copy the image and then paste the image, submit. Yes. So we have the image we got from iStock, and then the prediction results, 73% that it's confidence that it's yeast, and then yeah, the percentages for the different other let's paste the URL and submit. So yeah, this is the image, and then so we're supposed to get the results here. So let's go back here and paste the same URL here, and yes, this is the image. Okay. So the issue is the image URL. So let's come and pick another image. Go here. Okay, cute. So copy the image and then paste the image, submit. Yes. So we have the image we got from iStock, and then the prediction results, 73% that it's confidence that it's yeast, and then yeah, the percentages for the different other data that you've trained it with. So that's for the image classification, and we can now go to the sentiment analysis one. So yes, now these yeah, I can still see my screen. So these are Python-based machine learning model for predicting the sentiment in a movie review, if it's positive or negative. So I've opened it with Google Colab because the data set is from IMDb, but in this case I have it stored in my Google Drive. So yeah, so that's why we have it open from Google Colab. So basically, like we had said, the steps, the first step after we've identified the problem we want to solve, in this case we want to know the sentiment in this movie review, is it positive or negative? So we get the data, of which yeah, we have the data stored in the drive. This is the path. So these are libraries we're importing for that we'll use within the project. For example, the NLTK is for the natural language processing toolkit, and then we have the random for randomizing, because we want to get a random review. Yeah. And then yeah, and the other libraries, NumPy, Pandas, yes, Matplotlib, because we'll have some graphs in between as we visualize yeah, our data and what we have. So as we proceed, so the data, it's a CSV file that contains 50,000 reviews. So from index 0 to 49,999, and then these are supervised learning. So of course we have it labeled. For example, yeah, this review is positive, positive, this one is negative. Yeah, so that the model can be able to know this kind of reviews are positive and this kind of reviews are negative. Yeah, and then we continue. So we visualize the data set. It contains equal numbers of positive and negative reviews. And then, so for this case, we are the ones doing the processing of this data manually. So we get to reprocess the data, since the review contains everything. It has exclamations, it has, we call them stop words. We have some words that don't even have feelings, but in this case we won't remove those, but yeah, we want to clean this data. So we'll go ahead and we'll remove the stop words, we'll remove the exclamation marks, all these punctuations, any HTML tag, and just, yeah, so that you can have clean data as we proceed. And then, yes, so yes, and then after pre-processing the data, we get to, remember we have 50,000 reviews, so we need to have some of these for testing. So we divide out in the ratio of 90%, yeah, 90% data for training and 10% for testing. So yes, and then we proceed to split the data and tokenization. And yeah, tokenization is now splitting the whole review. And as you can see, we have the entries, the words, and then we proceed, and then we have the visualization. So from here now, all this while we are working on the data, and now we're supposed to move on to the model. So yeah, so here's the model we'll use in this case. We'll use the LSTM model, which is long-term, short-term memory. Yeah, for this, because of the nature of our data and what you're doing, and then yeah, all this is just importing a few libraries and all this. Now in the process of training, enabling a model to identify this is the positive, this is the negative, and yes, so we do that, and then yeah, more visualizations, and then yeah, we now come to, we said after we train the model, we get to evaluate the model so that we can check the accuracy. So yeah, that's where we are at right now, and then from there we can go to the results. So the results in this case, so like any model, we'll get to some errors at some point, whereby a review is positive, but the model identified as negative. So this is the error margin in our case, the true negatives, false positives, false negatives, and the true positives. Yeah, and on average, our model has an accuracy of 89. So yeah, because of the amount of data that we trained it with. And then so we now do a tests. So remember, we imported a library for randomizing. So at this point, you're telling it now randomly pick one of the reviews and check it out. Is it positive or negative? So it will first read the CSV file we have in our drive, and then yeah, randomize, pick just a random review, and then move it through the prediction model. And yeah, so we have this, the review. It chose review number 29,540, and so as you can see, what you've told it, if based on your prediction, it's over 0.5, yeah, we've given it a 50% cutoff. So if it's over 50, then positive. If it's under 50, then it's negative. So for the review that it randomly got, we have it as positive with the probability at 0.89. So yeah, time's gone. So yeah, basically that's what I had for us this morning with regards to machine learning. Yeah, and then yeah, we can have questions or feedback on yeah, where next can we move this, and yes, in any ideas of yeah, what's the next machine learning model that you can do, yeah, based on our needs and what you're doing. So yeah, that's all. Thank you.